Hey guys, Mr. Mackey here. Now yesterday I was showing you how to create and find the next terms in a geometric sequence and also what on earth they are. And I set you this challenge to find the first 5 terms of the sequence and find out if 300 belongs in it. So obviously let's find the first 5 terms, and for this we're going to do a bit of substitution. So for term number 1 it's 2 times 5 to the power of 1 minus 1. Well, 1 minus 1 is 0. Anything to the power of 0 is 1. So 2 times 1 is 2. That's the first term. So now term number 2. You do 2 times 5 to the power of 2 minus 1. So, what will that be? Well, 2 minus 1 is 1. 5 to the power of 1 is 5. So 2 times 5 will be 10. Let's do the next one, term number 3. So we do 2 times 5 to the power of 3 minus 1. 3 minus 1 is 2. 5 to the power of 2 is 25. 2 times 25 is 50. Now term number 4, it's 2 times 5 to the power of 4 minus 1. 4 minus 1 is 3. 5 to the power of 3 is 125. So 2 times 125 will get us 250. And now to get the 5th and final term, you do, so let me just write the 5 up here just so you know. We do 2 times 5 to the power of 5 minus 1. 5 minus 1 is 4. 5 to the power of 4 is 625. 2 times 625 is 1,250. Those are the first 5 terms. 2, 10, 50, 250, 1,250. Now from that we can also automatically tell that 300 is not in a sequence, because if it was, we've already gone past it. So the answer to this one is no. Now yesterday we were creating sequences using the nth term. Today we're going to be creating the nth term using the sequences. Let's get into it. Now I've got a geometric sequence here. This is term 1, which is 3, term 2 is 6, term 3 is 12, term 4 is 24, term 5 is 48, term 6 is 96, term 7 is 192, and it will go on from there, forever and ever. But we can find the nth term of this sequence from just this. How? I'll show you. Now the first thing we've got to do is we've got to look at what the first term is. It's 3. And the second term is 6. So how did you get from 3 to 6? Well, to get from 3 to 6, you multiply by 2. So the second term is basically 3 times 2. The third one is we go from 6 to 12. So you're timesing it by 2 again, which is the same as 3 times 2 times 2 again. How do you get to 24? You're timesing it by 2 again, so you do 3 times 2 times 2 times 2 again. Now this is getting a bit timesy-2y. That's a new word, put it in your dictionary. How can we make it a bit simpler? Well, 3 times 2 times 2 times 2 is the same as 3 times 2 to the power of 3. 3 times 2 times 2 is the same as 3 times 2 to the power of, well, 2. 3 times 2 is the same as just, well, 3 times 2 to the power of 1, which is the same as just 2. So what would the next one be? Well, for 48, if you're timesing it by 2 again, it would be 3 times 2 times 2 times 2 times 2, which is the same as 3 times 2 to the power of 4. So what is the nth term? Well, haven't you noticed that for the 4th term, it's the power of 3. To the 5th term, it's the power of 4. 3rd term, it's the power of 2. what you're doing it to the power of is always one less than the term you're doing. So, for the next one, it would be 3 times 2 to the power of 5, because we're taking away 1 from our term in the sequence, and it's the same all along. And this one would be 3 times 2 to the power of 6, because it's 7 and we're taking away 1. So how would we write the nth term? Well, you do our 3 times 2, and then it's to the power of n, because that's the nth term, minus 1. And that's how we create a geometric sequence. But what do the parts of the geometric sequence nth term mean? I'll show you. Now, when I started doing geometric sequences, there might have been something you noticed when you look at the rule and when you look at the sequence. Can you notice anything in particular? There's 2 things. The first thing, the start of the sequence is 3 times 2. Where else do we see a number 3? So, the 3 in the nth term actually means the first term of the sequence. So in this case, the first term of our geometric sequence is 3. What about the 2? What does the 2 mean? Well, the 2 is how much we're multiplying by every time. We're multiplying it by 2. So that means what we are multiplying by. So I'll just put times by. So, the method I showed you, where you go on for each of them doing 3 times 2 times 2 times 2 times 2, or 3 times 2 to the power of 4, another way you could just do it is when you have a sequence, if you know the first term, and what you are multiplying by each time, if you just substitute them into this, and you can just find the nth term from there. Let's do another one, and I'll show you what I mean. So all I want to do is I want to find the nth term of this sequence. So, how do I do it? Well, firstly, what's the first term? The first term is 100. So I'm going to write down here 100. And the second question is, what are we multiplying by each time? So how do we get from 100 to 50? 50 to 25? 25 to 12.5? Well, you're multiplying by a half every time. So the nth term would be 100 times a half to the power of n minus 1. And that is it. It's so simple when you think about it. So, I feel I've done enough on this. Here is your challenge for today. I have a sequence, a geometric sequence, but I only have the first 3 terms. But you only need the first 3 terms for this. And I want you to find for me the nth term and the 6th term from this sequence. See what you do, see how you write it, and tomorrow we're going to be looking at the final 2 and look forward to the next 2 days, because we're going to be looking over one more type of sequence. What sequence is it? Try and see if you can guess. But good luck with geometric sequences. Let's see how you do. Cannot wait. Have a good VE day, guys, and see you on the weekend.